All right, example 6 of 6.2, we want to find a volume of the solid whose base is the triangle formed by the lines x equals 0, so that's the y-axis, y equals 0, which is the x-axis, and then this line, y equals negative 1 half x plus 1. Okay, cross sections are perpendicular to the y-axis and they are equilateral triangles. Okay, so this one's a little funky. Let's again ignore the cross section portion of this problem statement and just focus on that first sentence. So let's sketch the region that's being described. Okay, so here we'll go ahead and draw our y-axis. Note that the y-axis is x equals 0, so that's one of our three curves we need to sketch. Y equals 0, so that's the x-axis. Again, that's y equals 0, so that's sketched. And then we have y equals negative 1 half x plus 1, so it's a line with a negative slope and a y-intercept of 1, so this would look something like this. So if this is a slope of negative a half, then this distance here, this x-intercept would have to be x equals 2. So this is x equals 2, and this is y equals 1. Okay. So then we have our cross sections that are perpendicular to the y-axis. So I'll go ahead and just draw a representative cross section at some, again, we are measuring from the x-axis. So this would be considered some arbitrary y value. Okay, so then out of the screen would come an equilateral triangle. So this triangle here, but not the way I have it, not exactly in this plane, but coming out of the screen towards you, directly outward. So if we go ahead and draw this triangle, okay, then we need to know what the area of this triangle is. Okay, so the length of this line segment, since it is attached to the y-axis, we are allowed to call this distance x. Furthermore, I didn't write this, but let me remind ourselves that this is the line 1 minus a half x. So we can solve this for x. So x would be equal to 2 times 1 minus y. Okay, so then that means the side length of this triangle is 2 minus 1 minus y. Now the area of a triangle, of course, is 1 half base times height. So we know that the base is 2 times the quantity 1 minus y. But then this height, for the height, what is this going to be? So to figure this out, we can just split this triangle in two. The height would be the length of this segment right here. So each of these, so this is a perpendicular bisector, so it splits this length in half. So really, we know that this triangle here, this base of this of either of these triangles, this base is exactly just 1 minus y. It is half of this distance. So this is 1 minus y. And then you can use you could use a number of things to get this. I would probably go ahead and just I know that we know that if this is an equilateral triangle, that means all the angles are equal. So that means all of these angles here are 60 degrees. So this would be pi over 3. So I would just say that the cosine of 60 degrees, or pi over 3 radians, that is equal to I guess maybe not cosine. I'm sorry. Let's go ahead and do tangent. Let's do tangent. So tangent of pi over 3 would be, we're going to do it for this angle right here, let's say. So if this is pi over 3, then opposite over adjacent. So this would be the height over that. Okay, so we can solve for, so the tangent of pi over 3 is the sine of pi over 3. Sine of pi over 3 is root 3 over 2. We're going to divide that by the cosine of pi over 3. Cosine of pi over 3 is a half. If we're dividing by a half, we're multiplying by the reciprocal. So the height is 1 minus y times root 3. So the area is, let's see, these 2's cancel. So then we're left with 1 minus y, this copy, times h, which is another copy of this, times the square root of 3. Okay, so now that's the area of that equilateral triangle. And since all of these triangles are being stacked in the y direction, we've got big triangles here, and then as we move up, they get smaller and smaller triangles. So the volume would be the integral from 0 to 1 of this cross-sectional area, which is our constant, root 3, and then 1 minus y, quantity squared dy. Again, we can use our integration technique, our little trick, because this inside function is a first-degree polynomial. We can just divide by the derivative of the inside. So negative 1 we're dividing by, so negative root 3. And then we would integrate this, so we'd have 1/3 1 minus y quantity cubed between 0 and 1. Which, when we plug in the top bound 1, we get 0. This term turns into 0, so we get 0 for that evaluation, minus a negative, so positive root 3 over 3 times 1 cubed. So this many, let's say the units are meters, so the volume would be meters cubed. So root 3 over 3 meters cubed.